Welcome to Ask and Learn.
Alright, so here is the problem 110 in chapter 19. Consider the following reaction: N2O4 gas and 2 of NO2 gas at equilibrium. So at what temperature, part A, at what temperature will an equilibrium mixture contain equal amount of the two gases? So for this equilibrium, the constant will be P of NO2 gas squared divided by the pressure of N2O4. So if we assume that equal amount will mean equal number of moles, so that will tell us the moles of N2O4 will be equal to moles of NO2 gas. So for ideal gas law, we know that PV equal to nRT. This is the ideal gas law. So from this equation, we know that the pressure will be equal to nRT divided by V. So in an equilibrium mixture, RT divided by V will be the same for the molecules. That is because R is a constant, temperature they're the same, and they're in the same volume. So P will only be proportional to N, and N is the moles of the molecules. And if N of N2O4 equal to the moles of NO2, so that will indicate that the pressure of N2O4 will be the same as the pressure of NO2. So now we can simplify the equilibrium constant K. Because this number are the same, they can cancel out. So the K will only be the pressure of NO2. So if we assume that P of NO2 equal to P of N2O4 is 1 atmosphere, this K value will only be equal to 1. And if K equal to 1, ln K will be equal to 0. So if ln K equal to 0, and at equilibrium, delta G0 is equal to 0, and that is equal to the delta H0 minus T, delta S0. So if delta H0 minus T, delta S0 equal to 0, we will get an expression for the temperature, that is the delta H0 divided by delta S0. So we can now calculate for the value of delta H0 and the delta S0. Delta H0 will be 2 times the delta H0 of the product, that is NO2 gas, minus the delta H0 of N2O4 gas. And this will be equal to 2 times 33.84 minus 9.66. This will give you 58.02 kilojoules. And the delta S of the reaction is 2 times S0 of NO2 gas minus S0 of N2O4 gas. And this is equal to 2 times 240.45 minus 304.3. This is equal to 0.176 kilojoules per Kelvin. So now we can calculate for the temperature. That is equal to the delta H0 divided by delta S0. And this is equal to 58.02 kilojoules divided by 0.176 kilojoules per Kelvin. And that will be equal to 328.5 Kelvin. So this is the temperature for part A. Now let's look at part B. Part B says that at what temperature will an equilibrium mixture of 1 atmosphere total pressure contain twice as much of NO2 as N2O4? So in this question, it tells us the total pressure, P total, equal to 1 atmosphere. Also, it tells us the P of NO2 is twice of P of N2O4. So if we assume the P of N2O4 equal to X, then the pressure of NO2 will be 2X. And we know the total pressure is just the sum of these two. So X plus 2X will be equal to 1 atmosphere. And we solve for this, X will equal to 1/3. So the pressure of N2O4 is equal to 1/3 atmosphere. And the pressure of NO2 will be equal to 2/3 atmosphere. So the equilibrium constant now has changed. It's equal to pressure of NO2 squared divided by pressure of N2O4, and that is 2/3 squared divided by 1/3. And this you will get a number of 1.33. So delta G equal to negative RT ln K. And delta G also equal to delta H minus T delta S. So delta H minus T delta S is equal to negative RT ln K. So if we plug in the numbers, we will have a formula of negative RT ln K equal to delta H0 minus T delta S0, negative 8.314 times 10 to the minus 3 kilojoules per Kelvin times T times ln of 1.33, that is equal to delta H is 58. We calculated from part A of this question, minus T times delta S, that is 0.176 kilojoules per Kelvin, and this unit is kilojoules. So we have one T right here and another T right here. If we move this term to the left side, we will get a new expression, that is negative 0.00239 kilojoules per Kelvin T plus 0.176 kilojoules per Kelvin T equal to 58.02 kilojoules. So combining these two terms, we will get 0.1742 kilojoules per Kelvin times T equal to 58.02 kilojoules. And then we can solve for this temperature right here is equal to 58.02 divided by 0.1742. That will be equal to 333 Kelvin. So this is the temperature for part B. Now let's look at question C. At what temperature will an equilibrium mixture of 10 atmosphere contains twice as much NO2 as N2O4? So in this question, P total has changed to 10 atmosphere. And once again, P of NO2 is twice of P of N2O4. So if we assume that P of N2O4 equal to X, P of NO2 will be 2X. And in this case, X plus 2X equal to 10. 3X equal to 10, X will be equal to 10^3. So the pressure of N2O4 will be 10^3 atmosphere, and the pressure of NO2 will be 20 divided by 3 atmosphere. So for this question, the equilibrium constant K will be P of NO2 squared divided by P of N2O4, 20 divided by 3 square divided by 10 divided by 3, and you will get the K equal to 13.33. And once again, minus RT ln K equal to delta H0 minus T delta S0, both equal to delta G0. So minus 8.314 times 10 to the minus 3 times T times ln of 13.3 is equal to 58.02 kilojoules minus T times 0.176 kilojoules per Kelvin. So we move this term to the left side and solve for T. We have negative 0.02154 kilojoules per Kelvin times T plus 0.176 kilojoules per Kelvin times T equal to 58.02 kilojoules. So this sum up, we will get 0.15506 kilojoules per K times T equal to 58.02 kilojoules. So the temperature will be 58.02 divided by 0.15506. That is equal to 374.2 Kelvin. So this is the temperature for question C.